Hello, everybody. Welcome to my biofuel presentation video. And in this biofuel, the biofuel I will be covering today is sustainable aviation fuel, also known as SAF. Now, the first question you're going to have is what is sustainable aviation fuel, also commonly referred to, as I previously mentioned, SAF, and how does it compare to conventional fuel methods? And then how can we overcome the challenges of implementing SAF, and why isn't it yet widespread? So let's first discuss the life cycle of sustainable aviation fuel. The first step of its life is collection. It is collected from cooking oil and feedstock, and then it is then sent to a purification facility where it undergoes the next step, which is conversion. The SAF is purified in a petrochemical facility, and this is to basically dry it out and make it much more combustible for once it's blended with the fuel. And that leads us into our third step, which is blending. Now, SAF is an additive to the fuel. It's not a fuel itself, as the name may imply. It is actually traditionally a 50-50 blend of traditional fuel and then the actual sustainable aviation fuel. However, Exxon is working to develop a variant which is 20% traditional and 80% SAF. Fueling, and that's the final step of this. Once it's after been blended and basically built, it is then sent to the fuel stocks, in which it is used in everything from general aviation aircraft to commercial airliners. So 80% is the big target number here, in which that is the percent reduction in emissions compared to standard aviation fuel. Commercial aviation is actually one of the most polluting industries on the planet. It puts billions upon billions of cubic tons of CO2 in the air each year, and the fuel waste is actually leaded. So traditional fuel that is used in like automobiles is unleaded because lead is a neurotoxin and is extremely toxic to human beings. But aviation fuel, unfortunately, is not. Let's compare the two. So traditional fuels are a petrochemical. They are made of liquid petroleum. They are unblended, so they come straight from crude to refinement to fuel, and they are the lowest cost option. SAF is, like I previously mentioned, made from food stock waste. It has significantly lower greenhouse gas emissions, but unfortunately, it is around 4 times more expensive than the traditional fuel that is presently available. And it's currently not available commercially worldwide, partly due because of that, in which we'll discuss on the next slide. So the current hurdles with sustainable aviation fuel, actually, COVID was a huge impactor of this because this technology began catching on around 2017, and unfortunately, due to the economic constraints that COVID has caused after basically nuking air travel over the pandemic, they have not been able to implement the technology due to funding problems. It basically boils down to supply and demand problems, along with basically just cost due to those supply and demand problems. The demand for the product is not yet there, so the supply isn't as prevalently available as traditional fueling methods, which is why it is so expensive. So how do we overcome these hurdles? The first priority obviously needs to be to increase the efficiency of the recycling. That is basically step one of the fuel's life cycle from our agricultural industries. And then the second basically being to force the fuel markets to adopt SAF because, you're not going to want to adopt a more expensive fuel. Nobody's going to want to eat that price hike. So you're going to have governments clamp down on environmental regulations to force companies to begin taking the more ecological option over the more economic option until the ecological option becomes the economic one. So now let's look at basically um, where we are at currently versus where we need to be. So this blue line here is the forecast growth for emissions in the amount of traditional jet fuel that is being produced per year. As you can see, 160 billion gallons by 2050. And then the red is the path that we have to take to get to net zero greenhouse gas and carbon emissions. The blue is the area between them, and we want that area to be as little as possible, ideally zero. And as you can see, we are not hitting that in the slightest. In fact, we're quite hitting the opposite. You can see the dip here just simply because of COVID during the pandemic, where air travel was essentially reduced to just cargo and essential travel only. About 20 billion gallons of fuel was cut, which is just the economic, uh, basically arrow to the knee that has not allowed this technology to take on. This is essentially concludes my presentation. I hope you guys found it informative. And yeah, just let me know your guys' feedback. Thank you so much.